Hello, my name is Steven Slumbo. We are looking at environmental science with respect to fluids at rest. A fluid is a substance that is free to move or flow, e.g. gases and liquids are classified as fluids. Fluids will exert pressure on the containers that is it contained in. So we are to look at pressure. And pressure is the force divided by the area on which the perpendicular force is acting. For example, if we look at a coin that is submerged in water, which experiences pressure caused by the weight of the water acting on it. This is the diagram showing us the water, that is the color that you have, the blue color is the water, and the direction, the arrow is showing the direction of the water pressure acting on this coin, which is an orange color. So the water in this container is exerting the pressure on the surfaces of the container and also on the coin. Now we want to derive the formula. We know that pressure is force over area, as we have already said, but then we also have another formula for pressure, which is density times acceleration due to gravity and then times height, as we have indicated in the formula. So in the first instance, we will be looking at pressure as F over A. So F over A, which is F is the force in newtons and A is the area in square meters. And then if we look at this container, you can see that we have the water in the container and exerting the force on this coin. So the column of the fluid, as it is indicated by the letter H, is the weight of the water which is acting on the column, on the surface of the coin. So we have the force of water being exerted onto the surface of the submerged coin. So F, to work out F, is the weight of the column height. So it's the weight of this column height of the water above the coin. And to determine or to find the value of F, or the weight of this column height of the water, is going to be mass times acceleration due to gravity, where mass is in kilograms and acceleration is meters per second squared. Now, since we are saying pressure is equal to force over area, and now we've just seen that force is equal to mass times acceleration due to gravity. Now we are going to substitute into the formula of we are going to substitute m times g, where we have F in our previous formula. So for this we mean our previous formula, this one, where we have F over A. So instead of F over A, instead of F, we are going to substitute m times g into another formula. So the formula becomes m times g over A. Now, if we consider the density of a fluid, the density of water, or the density of any fluid that we may have, so we have density is equal to mass over volume. But then making m the subject of the formula is going to be m is equal to the density times the volume, as we have seen it. And also we know that if we are to determine the volume, we have to multiply the area of the base times the height. So maybe if we go back to our diagram, if we want to determine the volume of this fluid, determining the volume of this fluid is going to be the area of the base, or area of that, the cross-sectional area, times the height of the fluid. That will be our volume. So volume is area of the base times height, as it is. That's going to be the way to go. So substituting P times V for M, we have, so in this we have density times volume. So substituting, because we have mass, so instead of mass, if we say P times V in the formula, then we are going to have a formula like this. So that is the mass goes, because originally we had M times G, so M has been replaced by density times volume. But we also worked out, that is, if we want to substitute this further, we've seen that the volume is equal to area of the base times height. So instead of having our volume here, we are going to replace V with A times H. So we have density times A times H times G over area. So this area and that area will cancel because it's the same value. So the formula now becomes density times height times acceleration due to gravity. So we have derived a formula for pressure, which is density times height times acceleration due to gravity. So now let's look at the example, see how we can work this one out. We have a rectangular sluice gate is 2.4 meters wide and is retaining water to a depth of 1.2 meters. Calculate the sideway thrust on the gate produced by the water, given that the density of the water is 1000 kilograms per cubic meter and the gravitational acceleration is 9.8. So it's supposed to be 9.81 meters per second, but if we express it to 2 decimal places, then it's going to be to 1 decimal place, it's going to be like that, but 9.81 meters per second. And now, since we have density, that's what we've been given, that is working now, we are working out that one. We have the density is 1000 kilograms per cubic meters, and also we have acceleration due to gravity, which is 9.81 meters per second squared, and the area, we've been given the dimension for the sluice gate. The sluice gate is a gate that controls the flow of water. You can close the flow of water in a canal or in an irrigation scheme. You can close or you can open, or you can maybe divert the water to maybe a certain area by either closing the gate or opening it. So that will be the sluice gate. Now we have acceleration due to gravity, which is 9.81 meters per second squared, and the area, we've been given the dimension 2.4 by 1.2. So if we multiply 2.4 by 1.2, we have 2.88 square meters, and the depth to the center of the area, because if we are to work out the force on the gate, then we have to determine the depth to the center of the gate. So the depth to the center of the gate is 1.2 divided by 2, so it's going to be 0.6 meters. And now the pressure through the center is going to be density times acceleration due to gravity and times the height. We cannot use the formula force over area because we don't know the force. So we therefore use the formula that we've just derived, which is density times acceleration due to gravity times height of the fluid. So since we have those figures, we just substitute the values that we've been given into this equation, into this formula. Then we have 1000 times 9.81 times 0.6, and the answer comes to 5886 pascals. So that is our pressure through the center of the gate. Now if we move on further, because we have been asked to determine the force through the sideway force on the gate. So to determine the force on the sideway gate, then we use this formula now. Pressure is equal to F over A. Now we make F the subject of the formula, and making F the subject of the formula is going to be F is equal to pressure times area. So we have worked out the pressure, which is 5886 and pascals, and the area is 2.88. We have already worked out that one, so we just have to substitute and multiply into the two figures. We have 16,000 951.68 newtons. So that's our area. That is if we are working out the area. So we'll continue from here in our next discussion, but if there are any problems or any questions, you can forward them to me so that we can see how we go about it. So for today, that's all that I've prepared. Thanks for your attention and watching. Until we meet next time, goodbye.